Hello, my name is Colton Bixler, and this is how I believe I proved the Lorenz transformation wrong. So, as you know, the Lorenz transformation is about a train traveling half the speed of light. So, I mapped out, and then there's also mirrors of which they bounce the light pattern. So, I mapped out the light pattern here. So, this is what Lorenz says that the light travels within the same distance. So I'm going to explain why the gamma is wrong, Einstein is wrong, and relativity is wrong just in this little explanation, because Lorenz developed the Lorenz transformation to fix an error in something that he did not know was an error. So with no further ado, let's go on to it. So here's the starting point. Let's say the train is moving this way. So here's the starting point, and it bounces here. Okay. So at the time it gets here, right, I've drawn out the light that travels. So if the light was only moving up and down, and it wasn't moving on a train, here's the path, right? Okay. And it would bounce between the mirrors this way. Okay. So if it bounced this way, right, this is the length of which the mirrors bounce back and forth. So, but the problem is that with Lorenz, he assumes that the train is pushing the light further, and I'm going to explain why the light didn't go further as far as what he thought it did, because light can only travel within this sphere. Okay. So by the time it hits to this wall and back and to this wall, it's the same time it gets to here. Okay. So this is how it's different. So he assumes that if we go half the speed of light, that this would go up here. But in reality, the same time that it takes from here to here is actually the same time it takes from here to here. So in reality, he thought the light traveled farther distance, but it didn't. Okay. See, because here is where this is the path. So by the time the light did actually get here, this little thing would move over here. The mirror would move over here. So it would miss its target. Okay. So he didn't understand. He did not understand how the light get from here to here in the same time it got from here to here. Right? That doesn't make sense, does it? You see, he made the wrong assumption. The light doesn't get here to here in the same time as it gets here to here. That was a false assumption. So what did he do with this extra 41%? He warps time. So hey, if I slow down time, that will explain why it got here. But in reality, it only got here. So you know what? So this is why thought experiments should not be taken for experimental data, because especially if it was actually performed a thought experiment, they would have come to that conclusion. But since they use a thought experiment, then that's it is. So why is there time dilation in satellites? Why do we have to constantly fix time dilation? Well, here's the kicker. Since he added this extra 41%, you have to warp time to adjust for the inaccuracy. Right here, that's the inaccuracy. He assumes it got here, so he calculates it as it did get here. So thus, slow down time to adjust for it. Well, you can't slow down time. Time doesn't exist in the way we think it does. Time is a measurement of motion. It's an equal distance of which matter moves within a given space. So right here, a photon moves from here, that's a given space. A photon moves here, that's a given space. That's time. If you try to say that the matter moved within a different time frame, which you can't because it's constant, you're therefore, that's where the error lies. So this is how I prove the Lorenz transformation wrong. There's other reasons, and my paper explains dark matter, dark energy, and the expanse of the universe. In my paper written in 2025, you can explaining all the phenomena due to the electrostatics and how most people come to roadblocks when it comes to certain facts and how I overcame them. Thank you, sir. Thank you.